All right. I think I'm going to share my screen now. Please, if you can see my screen, you should indicate, please. All right. Okay. I think I gave an assignment, and I'm very happy that at least some people attempted it. Okay. So in the assignment, I wanted you people to try out this. I wanted you guys to try out using the photoresistor to build the light and dark controlled bulb, right? Okay. Well, I think I'm going to start from here first. Let me drag out my board. Then the breadboard. All right. I wanted to like get some of the this thing assignments you guys submitted. So I think in some people's own, I was seeing something that if it was a real connection, I don't know what would have happened to you, Sha. So, all right. Sorry, if you have the starter kits, can I see your hands? Okay, just Uchenna. All right. There is an item that I want to work with, which is this. If you notice, this is not like the normal LED, like this LED. And if you have the starter kits, I know you should be seeing something that looks like a traffic light, something. It has red, it has yellow, it has green. Okay, so that's a three color LED. And that's what I want to introduce you all to right now. So before I use this, let me just make a connection. Let me just make a connection with this. All right, if I hover on this, I will see that this is the red leg. Then this is the cathode, which is the GND, right? The minus. Then this is the blue, and this is the green. All right. So if you have this, if you can see this physically, you will notice that it is not just like this LED. You know, this LED just have the bulb and then its two legs. But this, you will notice that it's not just like this. There are other things there. Now, What I wanted to point out is that this bulb is taking 3 point something volts, right? That was what I said. And before you can be able to connect this bulb, you need a resistor so that it won't burn your bulb. But with this, you don't need a resistor because there is an inbuilt resistor on it already. So it is not like this raw bulb. It is already built and there is a resistor on it. All right. So I won't be needing the resistor. I won't have to add the resistor. I can just connect it directly and nothing will happen to this bulb. So if you have the starter kit, you can just follow me up with what I'm doing. I don't know. Have you all opened the Tinker Card? So I won't just be doing this on my. Please, you can raise your hand to the Tinker. I think maybe I should continue. Maybe I should continue with the slide and then later we'll come back to the Tinker Card. By then, you all must have opened it. All right, so the program that I told you all that we're going to build today, um, I told you that we're going to actually build a smart home device. Okay, controlled by voice. So these are the components needed. We need the Arduino Uno board, the breadboard, jumper wires, then 4-channel relay module, the Bluetooth module, the light bulbs, and an electric fan. All right. I know this is actually confusing. This 4-channel relay module. I don't think I ever mentioned it before for now. So I'm just going to introduce you all to this relay. I don't know if you can see it very well. All right. So if you heard me clearly the day before yesterday, during our last class, I said something about that the Arduino gives out 5 volts. How about when you want to automate a device that takes in more than 5 volts, that works with more than 5 volts? How will you do this? So if you notice this bulb, the normal bulb, it takes more than 5 volts to turn on that. So for us to actually automate that bulb to actually work, we need something else, which is the relay module. And that is the work of it. All right. Sorry, give me a moment. All right. So this is the work of the relay module to help in this kind of situation. If you can see, this bulb is not directly powered by this Arduino board. You can see that the socket, that is the plug, is still there. But then we have the relay module, which is connected to the Arduino. All right. So I'm just going to explain the concept of the relay and how this relay actually works. Okay, if you can see here, there are 3 pins. There are 3 pins here. Okay, where you'll be able to unscrew and then attach your wire into it. All right. So these three ports have exactly what they are doing. The first one is normally closed. The second one is just the neutral. Then the third one is the normally. Now this relay has an electromagnet inside of it. So when it receives signal from the Arduino, it will either trigger the pin to the normally closed or the normally open. So when it's in the normally opened, that means this device will be on. So just take the relay as a switch, where you just press your switch and then you switch it off and then you switch it on again. So that's exactly what this relay is doing. Once it receives power signal, once it receives a high signal from the Arduino, it will switch to normally open, and then your device will be able to turn on because power can flow through it. But then when it receives a low signal, then it will switch to normally closed, and then your device will be short, so power can't flow through it again. So that is the concept of the relay. And with this relay, you can be able to plug your device in an AC current. Okay, you can be able to plug your device and still automate it. So unlike before, the normal bulb where you just directly connect it to the Arduino, and then you can't automate it if you don't connect it to the Arduino. But if this bulb is connected to the relay, then you connect the relay to your Arduino. So the relay will serve as the middleman there. It will receive signal and then trigger your bulb to do this or do that. All right. So I don't know if you understand the concept of the relay. So in order to help up your voltage, the relay is actually what is needed. And this thing you're seeing here is a one channel relay. So we have the 2 channel, we have 3 channel, we have 4 channel, up to 8 channel. Okay. So yeah, up to 8 channel relays. So this relay is actually used for home automations. All right. If you've opened the Tinker card, can you just raise your hand now so I can talk? It's just 3 people. I don't know what's the delay all about. All right. Okay, let's move forward to what we were doing before now.
Hello, ma'am. Sorry.
Yeah, I can hear you.
Before you proceed, sorry.
Okay.
I think maybe I might be the one who is making mistake. But you said something that if the relay receives signals, a power signal from the Arduino, then when it goes to normally close, then
Yes.
it stops working. But if it goes to normally open, that is when it receives power to work, right?
Yeah, it will receive power to actually trigger the bulb to switch on.
When it's
But
on normally
closed, when it's on normally open.
but why I'm asking is that I don't know, but when it is like according to electrical concepts, so when it is in open, it means that it is broken, like no connections, and when it is closed, that is when there are connections or something like that. So that's why I'm trying to. I don't know. I don't understand that part. I don't know if you understand my
Okay.
question. So
Yeah, I understand what you're trying to say.
okay.
All right. I'm actually trying to check for a relay here. Let me see. All right, I think let's just continue with this. I'll come back to the relay. So when I want to build the project, then I'll continue from there. Okay, all right. I was saying something about this having a built-in resistor, so you don't need to add a resistor to this for it to be able to work. Now, if you hover on this is the red pin. You hover on this is the cathode, that is the minus. You hover on this, you see that is blue, and this is green. Okay. Then let's connect the minus just like this. Yes. All right. So remember to connect this GND to the Arduino GND. All right. Then we connect the plus to the 5V. Okay. Then this is the red. Although we are not going to connect anything to this plus, because just like I said, if you connect this to this plus, that means it's not connected to the Arduino, and the Arduino is not going to control it. So for us to be able to control this, we have to connect it to the pins, digital pins of the Arduino, so that when we turn the pins, when we turn the pins to high or low, then it will be able to control this board. Okay, just like this. If I do this, then I don't know why this is taking so much. Okay. Yeah, you can see this, right? So this is just on. Although we didn't write any code for it, right? But it's on. So that is because we didn't connect to any digital pin of the Arduino. It's just being controlled by the plus and minus. Yes, because is in the plus and its other leg is in the minus, to definitely work. All right. So I'm going to delete this. Then this is the red. So maybe we can connect the red to pin 8. Okay, let's connect to pin 2. You know, you can connect to any pin apart from 0 and 1. I don't know, you should try to make your own diagram as good as possible. So yes, I say so. And I'm not using a resistor here. I'm working according to the LED you could have in your board. Sorry, in the kit. So there's a resistor there. There's a resistor there. It's not just like the other bulb. So you don't need to actually add a resistor here. That's why, as you can see, I'm connecting it directly. I'm connecting it directly. I'm not using a resistor. Okay, if it was the normal bulb, before I connect this to the power pin, I will have to put a resistor so that the resistor can actually regulate the flow of the voltage between them. All right. Okay. Um, all right. So this is it. The red is connected to pin 2. So whenever I trigger the pin 2, then the red will automatically turn on. Then the blue is in pin what? I just confused myself here. 3. Okay, blue is in pin 3. So whenever I give power to pin 3, that means I'm telling you to on the blue light. And the last one, that is the green, is in pin 4. So whenever I give power to pin 4, then the green light will come on. And if I start simulation, you'll see that it's not going to work. It's not going to work because there is no power yet on these pins. All right. I think there is something I missed. There is something I missed before about pin 13. Now, pin 13 is the Arduino power pin. By default, pin 13 is activated. I don't know if you got that. So immediately I turn on the Arduino, pin 13 has power already. Pin 13 is activated. Unlike the other pins, as you can see, when I just test simulation and then it's off because those other pins, they are let me say there's no power in it. But pin 13, I think, let me just stop this and then connect something to pin 13. All right, I don't know if you saw exactly what happened. That is because by default, there is power in pin 13. by default. But in the other pins, you have to write high or low to be able to trigger it. So if you're working with pin 13, that means in your code, you have to turn it low first. That is, assuming you want to off it by default. Because by default, it's on. That pin has power in it by default. So assuming you want to off the device on it, immediately you start writing your code, you can just write, you can just use a low signal for it so that when the operator loads, it will switch off pin 13. All right, so these are just the reserved pins in the Arduino. I don't know if you got that particular explanation. If you got that, you can just raise up your hand. Okay, all right. I think let me take it back to where it was. I don't want to use pin 13. Okay, let me stop simulation. Yes, that was in pin 4. All right, so let's write the code. Remember, in the Arduino, you're not going to be using these blocks. So it's better you start writing your code by yourself. All right, so this is just the default code that they are giving us here. All right, let's declare the pins here. And let me name it red is equal to 2. So the red color is in pin 2 of the Arduino board. Pin green is equal to 4. And pin, what's the other color? Blue is equal to 3. If you have the physical LED that I'm talking about, you look at it, you see that it's labeled. The green is labeled, the yellow is, I think, where you have should be red, yellow, and green as traffic lights. So, and it's labeled. So you can just do your connection based on the label. Remember to set the state of your pins, either input or output. So this LED, they are all output devices. Sorry, I don't know if you all can hear me. Someone is trying to check my mic. Please confirm if you can hear me.
It looks like the pitch of your voice is going low and coming high. Maybe your microphone or something.
All right.
I don't know if I'm the only one who is having the issue.
I think others should please confirm this.
I think there's a breakage from your voice. There's a breakage. It's going high and low, high and low.
Oh, wow. Is it okay now?
Better.
All right. Okay, pin mode. Let's set the state of the red pin. Red is out. Pin mode. Okay, I don't know, guys. Just remember that this is actually a variable. The red, the green, and blue is actually a variable. So assuming I didn't want to use this this variable, I could just do this. So I'm just trying to set the state of all these pins. All right, and I stored the pins in a variable. So instead of writing pin 2 directly, I will just name the variable. And you know the value of that variable is 2, so it's the same thing. All right. Pin mode 2, red is output, green is output, pin mode blue is output. All right, so let's do this. Digital right, red, high. So we're going to start with the red and then delay, maybe 5,000. That is for 5 seconds. Then it's with okay, red, low. Then we switch on the yellow, right? Okay, not yellow, blue. Blue high, delay, maybe 2,000. Then blue, I think I'm just going to copy and paste. It's just follow me up. Blue low. You should remember your comments. So maybe you can just comment on this. Turning on the green and all right, green high. Delay 5,000. Then green low. All right. Like I said, we are working with one LED, but then they are connected with their different pins to their different legs are connected to like different pins of their. So what we just want is to send either a high or low signal to that pin, and whatever is connected to it will act according to what we send to the pin. So all we are just working with is the pins. You can see digital right, green, high. That means green is 4, right? That means I'm sending a high signal. That means I'm sending a high signal to pin 4. And it will receive power. Whatever is in it will allow power to flow through it, and then it will turn on. So, and vice versa. So I think let me change this back to the variable load. All right, let me start simulation. Okay, so this is it. All right. The red, you stay for 5 seconds. Then to turn off, switch the blue, then switch the green. All right, so the red comes up again, the blue, and the green. So if this is working for you, you can just raise up the hand.
have to see the code panel again. Oh.
Okay. This is the code. All right, so I guess many people are here already.
Well, I think you should also add the comments for the blue, saying that you've done that for the green already, so it doesn't look so confusing. And it's not looking
Okay.
confusing to me though, but so it just looks nice and neat.
All right, so let me stop simulating and turning on the blue LED. Turning on the red LED. All right, so I guess it's better now. Okay. All right, please follow me. I'm going to create a new design. Let me just do some corrections on the I think I've not worked with the sensor before now to be able to read from the sensor and then so that is what we are going to do now. Let me just work with the photoresistor. Okay, first of all, I'll just get the breadboard. Then I'll get the resistor, that is the photoresistor. And the Arduino board. All right, yeah, we should also have our bulb, right? Okay, I think let's connect the bulb first. This is the anode, then this is the cathode. Always the minus. Then let's connect this to Arduino GND. All right. Then remember, we need to connect the resistor to this. All right, so I can just put it on this pin. Okay. Then I'll get my resistor. Okay. I'll connect the resistor to this. Where is the resistor?
Helen, please, as I'm seeing this thing, you're not connected to GNT. I think you're connecting to the other ALEF.
Sorry, I didn't get that.
So, I don't think you're connected to GND. Look at where you pin the GND. It's like you're connected to the other pin. Yeah.
Wow, thank you so much for this. Thank you so much for this.
Okay. You can delete that one if it is being difficult to connect. Delete it and draw this thing again. Yeah, you can delete the line, the bar, then draw it again. Yeah.
Let me draw this again.
Yeah.
All right.
Yes, yes. Yeah.
Okay, yeah, I think I'm connected to GND now.
Yes, yes.
And let me not forget to connect to 5V. All right. I'm going to rotate this, and I think just like the former one, I know what I did before now was facing this way. Yeah, it was like this. So I don't want to do that again. All right. Now, as you can see, remember that these pins are all connected, but this pin 9, that is where the LED is connected, and pin 10 are not connected in any way. Okay, so this is what happened. I connected one leg of the resistor to where the LED is, and I extended the other leg to a different pin. All right, so this connection now, that means I'm trying to extend this connection to this other pin. And I think, let's see. All right. So remember, the power is coming from this pin 2. And then when it comes here, the resistor here will like regulate the flow of that is the voltage, regulate it, and then power the LED. I don't know if you understand that. All right, so just like this, the LED is already connected. I think, let me see the code. Just to be sure that when I give power to pin 2, that the LED is connected, LED is equal to 2. The pin mode LED output, then digital write LED high. All right. Okay, is on. Yeah, so it's correct. Okay then. So how do I connect and read from this? That is the photoresistor. Terminal 1 and terminal 2. Okay, so with this, I can just choose my negative and positive. So I can just choose the one I want to use. All right. Okay. Let me extend this to the breadboard and this also to the breadboard. You know that these two pins are not connected in any way. That is why it could stay. So I could see that some people are doing this kind of thing. Let me just rotate. Okay. So some people are doing this. No, this is very wrong because these lines, they are all connected and you are connecting minus to that same line and connecting plus to that same line. That means it's just like taking your positive and negative and joining them together. So that is exactly what this is doing. I saw that this is exactly what some people did. That this positive and negative, you shouldn't join them together here. So it's just like you are joining them together and it's wrong. So for you to do this, you need to connect them to two different pins. Two different pins, just like this. Pin 29 and pin 30 are not connected in any way. So you just do this. All right. Okay, I'm going to bring in a resistor here. I'm going to bring in a resistor. So we need a resistor for this photoresistor. All right. So remember that this is actually a sensor, and we are not going to work with the digital pin. We are going to work with the analog pin because we want to get continuous stream of input data. Also remember that in the state, it will no longer be output, but the state will be input now because the resistor is actually an device that trying to get data through it. Okay. Um, just trying to see. All right. One end of this will go to the minus. Yeah. And then one end of this will go to A0. Okay, then this will go to plus. All right. So it's just like this is the positive pin and this is the negative pin. All right. But then we need to add a resistor between the negative pin. Connect one end of the resistor to A0 and then connect the other end to the minus. But this one remains the power pin. It will just be in the plus. Okay, let's see. First, so that you won't forget, this everything might not actually work if you don't put this state. You'll be writing digital right, analog right, and all that, and still it will not work. That is if you don't put this state. Okay, I think hint. Now this is also called an LDR, a light dependent resistor. A light dependent resistor. So it's also called an LDR. Then I'll say in LDR equal to A0. Okay, do you have any questions? Any question with this A0? All right, Uche Naya.
Okay, thank you so much for the question. Quickly, I was thinking I will forget about the question. Could it be any? Could it be any of the analog pin? Could it be
Yes.
A1? Could it be A2? Could it be A3? Okay.
Yes,
Okay, and
just
then
like it can be any of the digital pins. It can just be any of the analog.
oh, all right. Then the photoresistor, we didn't connect. I didn't see you connecting the positive line to any in the Arduino board. Must this just stay here? And what I'm asking is you connected the negative and the negative line to
All
the
right.
A0, if I'm not mistaken. Then the positive is just be on the breadboard. And then from the breadboard, I didn't see any connection. It's not running down to the Arduino board. Should I don't know. Is that how it's supposed to be, or I've not seen any connection to the Arduino board from the positive line.
All right. Now remember that there's actually a connection to the Arduino board, and this is it.
Oh, okay. Oh, okay.
A0.
Sorry. Okay, hold on. Sorry, I'm coming. Okay, the 5 volts. The 5 volts, right?
This is the 5 volts. This is connected to plus.
Okay, yeah. That's the
Remember
positive.
that plus is the 5 volts. So the Arduino positive is connected to 5V, right? So all these lines, as far as there is anything on this line, is already in 5V.
Okay. Okay. I didn't see that. I didn't see that very well. Sorry, carry on.
Okay, so I think I was expecting a question here. In number 4. No question there.
Please, hello.
Yeah, I can hear you.
Can anyone hear me?
Yeah, I can hear you, Erickson.
Okay. Please, I would like to know this photoresistor. Does it have any polarity? How do you identify the positive and the negative? Because when using LED, you could see cathode and anode, and then when you go to resistor, you see terminal 1 and terminal 2. Is there any way to know which one is the negative and which one is the positive?
All right, can you hear me?
Yes, I can.
Okay, so you won't just see this in only the photoresistor. So when you come across many other components, you will see that some components like they don't really label this is positive and this is negative for you. So which shows that this is a kind of component that you can just connect and then make out your positive and negative. I don't know if you got that. It's just like what I did here. It's just like what I did here. I could have used this terminal 1. Are you there? I could have used it to do this connection, to add the photoresistor there and then connect minus from there. I could have used it. And I could have used terminal 2 to connect to 5V instead. I don't know if you're getting me.
Yes, yes.
Yeah, so I can just use any of the terminals as my positive or negative to do my connection.
Okay.
Apart from the ones specified. All right, because people already built this. So they might just like, okay, this is the positive pin and it will be labeled on it. So in the case where it is not labeled, in the case where the positive or negative is not labeled, that means anyone can just serve according to, just like this. If I connect it to 5V, right, that means what is flowing to that pin is 5V, and there is no problem. So just don't miss the connect. Whichever one you've chosen as your positive or negative, don't mix it up. That is just it.
Okay. Thank you.
All right. I was saying something about, okay.
The question.
Yeah.
So in the code, so I don't know, you're trying to get the digital inputs twice. I don't know, are you trying to, like, in the setup mode? So we just have just one
I was trying to write something here. You know exactly what I want to write, but I need to name my variable. That's why I just copied this and pasted here.
And
so I'm still going to edit what I wrote here. Yeah.
Okay, one more thing. So I understand that this pin modes and passing in some parameters, I understand that they are supposed to do things. And is there a way, I know this is a simulation software, but is there a way that we could, someone could actually see the function of how it is written, like this pin mode? I don't know, maybe it's kind of a function that is supposed to perform something, but we just try to pass some parameters. So is there a way that we could see on the simulation software the codes written for the commands?
Written for this?
Like
for this pin mode?
Digital, like I did just C++ keywords or something. Like this pin mode, you're passing through
parameters. I think I know what you're trying to ask. So I will just give you which language do you write?
Python.
Okay. It's just like you saying you want to actually see the code that is making Python to print. I don't know if you understand.
Yeah, no, the thing is, sorry, but you know, there are some modules where you can import something and they already wrote that this thing you are importing should do something. You just pass it at the front end. You know what
is that? You know exactly what is an inbuilt function, right?
Yeah.
Yeah, so
I know what
is an inbuilt function. Okay. Assuming I was working with a library, right? You are still going to see some things like that. Assuming I'm like trying to import a library and then work with the library, then I will have to import the library. As you can see, I'm not importing any library. So whatever I'm using here is the inbuilt functions.
Yeah, okay, yeah, that is exactly what I wanted to know. Whether it is a C++.
Yeah, so it's not a library. It's not a library. It's an inbuilt function. Not a C++ inbuilt function, but an Arduino inbuilt. Because if you write this in C++, it's obviously I don't know if you're getting it. So this is Arduino language that we're writing, but it runs on C++.
Oh, yeah, I get it now. It's not a C++ function, but a function in Arduino that
is an Arduino, something. Yes, is an Arduino inbuilt function that performs something. So it's not a library. You still get to a point where we have to include libraries like the 12C connector and all that.
Okay.
Okay, I don't know. Can I go on? I just saw something I want to ask about it. Sorry.
Okay.
On line 4, I don't know.
Okay.
The A0 strings and numbers. I don't know. I don't know about C++, but I
Alright.
write on JavaScript. I write on JavaScript though, but
Alright,
I
so
think
that was actually the question I expected you all to ask me.
okay. Okay.
Okay, because I know I
Okay.
clearly said that integers are just numbers, right? So how then are we declaring int LDR and then assigning a to it, even without the string? You know, if we wanted to use this as a string, we'd have added the string this thing, right?
Yeah.
So, and it will still understand it. So now, these analog pins, are you getting me? They have their inbuilt ID. So they have their inbuilt ID. Now, this A0 you're seeing here is just like a variable already declared. Are you getting me? And the value is equal to that the inbuilt ID of this pin. So it's just as if someone have done this in A0 is equal to blah 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 blah. Are you getting me? And it will understand when you do this. That means this ID, these numbers, let me just assume that is the ID of this pin A0. So it's as if someone have done this. And when I say int LDR is equal to A0, that means is this. Do you understand what I just said?
Yes, I do. Yes, I do.
Okay.
Yeah,
And this ID is not just something that we can, unlike the 2, 1, and others. This ID might not be something that we can understand or work with. So that is it. Once you declare A0, we are just saying that int LDR is equal to variable A0. Whatever value this variable has, just let it be what it has. So that is it.
Okay, Helen, let me ask a question, please. This
Okay.
AO is positive connections, right? Those analog pins.
Yes.
Yeah, A1. But I noticed in this photoresistor, the
Yes.
first pin is on positive at the breadboard. The positive, the first leg is at the positive. Then the second leg is also going to the analog positive connection. So I thought maybe one should go to the negative direct. I'm just trying to understand the connection you did there.
All right. Now I don't know. Let me see. All right. Let me see. Image of a relay module.
This one I will password this one. Yeah, email address. Password, yeah, email compare this thing that translates na this thing mama or the as password and just say gap say na thing with that translator. What did you
All
say?
right. Sorry. I don't know. Someone is trying to maybe you can. Who asked the question? Frank, right?
Yes.
Okay. So I actually wanted to show you something. Now, this is a module. But then, where is this again? This thing you're seeing here is just having 2 pins. Now, you can actually get a photoresistor. You can actually get a photoresistor that is on this. I don't know if you're getting me. That is on this, and someone else have already programmed it, and these pins are there for you. Normally, what we need for this, we need 3 pins for this. So that is why, as you can see on this relay module, there are 3 pins. You can see the label, right? We have the input pin, we have the GND, right?
Okay.
And we have the VCC.
Okay.
All right. Now, you know that this is actually a module that someone has. I don't know, if you go to the market and you get the normal relay, I know electrical students here should be able to understand. The normal relay that you is not like this. If you've seen the one,
Okay.
it's not like this. It's not built on this. So the normal relay, the only thing you will see is this blue box. That is the only thing. But someone have already done the connection inside, right? And brought out this for you. So that it will be easy for you to just attach your wires and then pin something here and this relay work the way you put it. Now, this is exactly what is happening here. This is just like that raw relay that you know. You know, the electrical students here, there's a kind of relay that you know. So this is just like that relay. It's only having 2 terminals, right? But then we don't need only 2 terminals. We need 3 terminals. We need to connect the signal, right? We need a signal for to be able to talk with it. We need the positive and we need the negative.
Okay.
So that is why this connection is like this. We had to, use a resistor and then get the negative from this place and then also get A0 from here. I don't know if you got that. So because we need 3 legs, we just had to do this.
Okay.
Yes.
Okay.
So you might not really find all these connections. So some modules are actually meant to be connected in a certain way. Some are meant to be added a resistor. We need to add a resistor to some. We need to connect some to in this way or that way. So this one is just like I don't know. There is actually a resistor you get. There's a photoresistor you get. I don't understand what you're asking. So there is a photoresistor you will get, and then it will be built on this module. The pins will be there for you. They will show you VCC, GM, and signal. S means signal. I input. And then all you just have to do is connect VCC, connect GND, connect this. Simple. But then this particular one we are seeing here only have 2 terminals. So we need to do the other thing there.
Okay.
Yes.
Okay. Okay, I understand. Thank you. One more question, please. And the code that you, how do we, because when I'm trying to write some code, I'll dial photoresistor. So I didn't know where to start off. Is that
yes, so I'm actually going to do that now. So after the code then.
Okay. Okay, if you understand what I mean. All right, thank you.
Okay, Uche, now you're asking what the photoresistor is. That is actually a light dependent resistor. So it can be able to detect when there is daylight. It can be able to detect the amount of light that falls through. It can detect that, oh, there is no light coming, so it's dark. It can detect that, okay, this is the amount of light coming. All right, so I think we are going to do something here and you will see it. I'm going to, the state of this should be input. That is LDR. Yes, LDR input. Then for you to be able to get values from these sensors, it will no longer be digital, right? Remember, this is analog. We are not working with the digital pins. We are working with the analog pins. So what we'll do is, I think let's just declare a variable int LDR reading, just to store the reading of this light dependent resistor there, is equal to analog read. Analog read. So which analog pin are we trying to read from? That is A0. and we stored A0 in LDR, in variable LDR. So we can just put LDR here. LDR. All right. Okay, then remember the if statement. This is actually going to give a particular reading. Okay. I think I missed something. I'm going to use the serial. Let's use the serial mode here. So you notice that sometimes we connect this Arduino to our system, but then we want to read the values coming from these sensors. So that is where the serial monitor comes in. So I'm going to declare the baud rate of the serial. I'm just going to say serial.begin. So this enables your device to be able to communicate with the computer. You can print something from your device to the computer, and then you can send information from your computer to this Arduino because of this serial. So I'm setting the baud rate to 9,600. All right. Then what I need to do next is serial.print. I want to print something to the serial monitor where I will be able to see exactly what I'm doing. LDR. Serial.print. I know you should understand what .print means. So that's a way of printing out to the monitor. In C++, I thought about C out, C out. So that's the same thing as print. They are doing exactly the same. All right.
Print LN.
That's if I actually want to write a line.
Okay.
So is not a must. Remember the end L, right? The end line. So that is the same thing that print LN is doing. If I use just print, then it will just be attaching everything to itself. There will not be a line space.
Okay.
Yes. Okay, let me see. Okay. Sorry, if you are following this connection, you can just raise your hand. Let me be sure I'm not working alone. Two people. All right.
Helen, if I may ask,
Okay.
the code you wrote, I thought there should
Yes.
be if a statement there, if the temperature is less than some amount like 500, then it should power on. If not, because I saw
Um,
one in the resistor, photo resistor.
exactly. I have to use an if statement, but I'm not done with my code. I just said, let me print out my reading, right? When I print out my reading, I'll be able to see. Then I will do my conditional statement.
Okay. All right.
Okay.
So sorry, can I ask a question, please?
Okay, it's fine.
Oh, sorry. Sorry, from that Syria begin 9,600. So I don't
Okay.
understand what it means, right? And the Syria dot begin, what it is though, and then the Syria dot print, the analog way also. I'm just trying to understand what you're trying to do there, so I don't get lost. Can you please just
Okay.
recap for me? I'm very sorry.
All right. I was saying something that the Syria enables communication, right, between two devices. And you know that this is actually the microcontroller. So whenever this port, right, is connected to your system, this Syria will help to be able to establish a connection between this board and your system. So whatever is going on this board, you can be able to send information to your system, like print something to your system from this board. And from your system, you can be able to send information, and that is the serial. So now, for example, we are trying to run this code, right? That is, if physically we just connected the light dependent resistor and then we connected the LED and everything, then we are running this. As far as, remember, this has to be connected to your system ports. So as far as it's connected to your system, then we can be able to start the serial. Just begin the serial with this baud rate, 9,000. So that is the communication. We want to begin a communication between the board and your system. And we can be able to print to the serial.print. So we are printing something just like the C out, whereby something will actually appear on the monitor. So we want to send information to the system through this serial. I don't know, it will make more sense if I'm actually using the Arduino microcontroller, then I'm doing it right so that we see exactly what will happen. Okay, I think let me do this. Okay, sorry, give me a moment. Let me choose.
I'm unable to see anything. Okay, okay. I can
Okay, you
now.
can see me now, right?
Yes, yes, I can.
All right, so you can see this, right? You can see this.
Yeah,
Yes, we can.
the Arduino board. Yeah, we can.
Okay.
Yeah,
Okay, the
yes.
Arduino board. And you can see the breadboard.
Yes, if you can just shift your hand to the right a little, that does it. Thank you.
Okay. Okay, can you see this?
Yes.
You have a photoresist.
Do you recognize
Photo,
that?
photoresistor.
The LDL.
Okay, all right. Okay. You can see this, right?
Yes.
Are those jumper cables?
So these are jumper wires.
Jumper
In case,
wires.
yes, you're thinking of what you can use to do your connection. You know, this is just a software and everything is just like, okay, so I guess this will be more realistic. Okay. Then these are also jumper wires. We have different kinds of jumper wires. We have the male to male, just like this. This is the male pin to male pin. So the two ends are male. Then we have the male to female. This is the male pin. That is this. This is the male pin, and then this is a female pin. You understand, right? Do you understand that?
Yes, yes.
Okay.
Sorry, I have to ask.
Okay.
When you say male to female, just to be clear, it
All right.
means one that can be pushed into the other, right?
Yes, one can be pushed into the other.
Okay, okay. Thank you.
Okay, just like the breadboard, you know, the breadboard actually have holes. So if you want to connect the breadboard, you know that you need to push the male into it. So we need a male pin to go to the breadboard.
Wow.
All right, so the same connection I did in the software is the same thing I'm going to do right now with the photoresistor. So you might not be able to see it clearly, just look at the software. That is exactly the same thing I'm going to do. And I'll just be very fast. Minus to GND and the plus to 5V. to A0. And this to minus. All right. So I think I'm done with this.
Please, can I ask a question why you're connecting the cables?
Yeah, fine.
I would like to know the presence of light on a photoresistor. Does it increase the resistance or decrease the resistance? What's the effect of light on the photoresistor?
Okay, sorry, give me a moment.
Okay.
All right, you can see this. Remind me so I won't forget that question. You can see this, right?
Yes, the cable, Arduino cable to the system.
Okay, yeah. So that's the Arduino cable. And I'll plug it in. I just plug it into the Arduino. And the other to the cable. Let me just upload the code then. All right, I'm going to share my screen here. So okay, confirm if you can see my screen. Can you see that? Sorry, can you see my screen, please?
Yes, we can, ma'am.
I can.
All right, so this is just like the Arduino interface now. So this is where you write the code and everything. I'm out of that other software now. I just feel like I'm doing something physical and I'm trying to connect it. So you see, if I want to upload something, the board is already connected. I will just click on this. And you can see here, it's just the progress. Okay, and I'll be able to see it uploading. All right. Okay. All right. You can see done uploading. So I just uploaded it. This. Let me use. All right, so this is plugged in. I'm just trying to show you exactly what the serial does. Now, if I hover on these tools, I'll see something, serial monitor, and I'll be able to open it. I don't know if you can see what this serial is showing. Can you see it?
Yes, we can see it. Yeah.
Okay, so this serial is showing 14. So that is actually like trying to show you the reading of this photoresistor. Because I say I'm printing something, right? I'm trying to print something. Okay, let's see. Analog read LDR, then serial.println. Whatever I'm reading from the photoresistor, that's what I want to print. All right, let's see. Okay, so it's just trying to establish a connection between the board that I just plugged in and this Arduino. So the Arduino is in my computer, right? Remember, this board is just on its own. But why then do I keep getting reading from a sensor in this board through my computer? So that is because of the serial. If I remove this, let me see. Let me just remove the serial.begin. All right, let me open the serial monitor. Can you see anything? Okay. By default, the baud rate is still 9,600.
I was thinking it has to be uploaded on the board first. Because isn't how it works.
Yes, it's not uploaded yet. Okay, so I just uploaded. I don't know. Can you see anything?
No.
Okay, so that's actually because like there is no, I didn't declare the serial. So I didn't actually start the serial. Even with the whole serial.print, even with this, it can't print to the serial because I didn't declare it here. All right, so I have to set the baud rate on which this serial is going to operate. So serial.begin 9,600. Let me upload again. Remember, I need to upload because these codes are being uploaded to the board. So whatever is in the board is what will keep executing. It doesn't matter if I already changed the code here. If it's not in the board, it will do something else. So the code is already in the board, and the board is now what is controlling every device is connected to it. So that's why if you notice when I removed this thing, I went and the board is still running the previous code that was on it until, okay, some people will be like, how can you delete a code? So you can't delete a code. All you can do is to upload. Like when you upload, the previous code in the board will disappear and the new one will start working. So exactly, if you want to like delete your codes from the board and everything, you can just upload an empty Arduino. That is an empty program, and everything will stop. So the new one is overriding the previous one. That is how the board works. All right, so I also wanted to show like how the serial communication and everything. And if I open the serial monitor now, I think I just uploaded this. If I open the serial monitor, you can see it's still showing 14, 14, 14. And I'm going to unplug the Arduino wire right now. I just did and it stopped. So the connection, it can't find the device to communicate with again. But once I plug in that port, I will be able to see all this in the serial monitor. I don't know if you understand that. Someone asked the question, please, did you understand now? I don't know. Can you all still hear me?
Yes, we
Someone
can hear
asked
you.
this question. Do you understand now, please?
So Helen, I wasn't the one who asked the question actually, but I'm gonna like assume that the concept of this serial writing the serial may not be significant to maybe a practical input, because we don't need to print out, like the program already can detect. So this is just for like visual purpose, right? Like,
it's not entirely for visual purpose. It's just like what we are trying to do now. So you know that we need to check what particular reading is the photoresistor reading, like is the photoresistor reading dark. I don't know if you understand. So we can just use this for testing while building.
yeah, like that's what I'm saying. Like in
Yeah, it's just for testing while building. When it's not connected, you know that when I think after the development, we no longer plug it. You can't be carrying your system around powering the Arduino. So we plug in, this time around, we plug in a battery or something else to power the Arduino. And we can't read from the serial again. Instead, what we can be able to do is um, to use another screen. I think, let me get a screen and show you. So what we all need to do is to use another screen. Something like this.
okay,
Can you see that?
like a digital screen.
So just like this screen. I can just connect this. You can see the pins, right? I will connect it to the Arduino, and then I will be able to write to the screen. And the screen will be showing something. So whatever I want to write, I can write it to this screen if I want to show the person. Maybe you want to actually tell someone, oh yeah, enter your name, enter this. So this is what the screen is all about. You can get bigger screens, all sizes of screens. So you can get the one that is 1 × 5 of this. Bigger screens, even the one that can show images. So this one is just text. It can just show only text because it's just only 2 lines. It will show only 2 lines, not more than 2 lines.
Yes. So the purpose of that, what I'm asking is, I think the computer or program doesn't really care about printing. This is just for human visualization, right? So for the day and night sensor to work, with the computer doesn't need anything to, right? You already understand what it's supposed to do, right? So printing to screen is just
You
for
already
visual,
understand.
for
So
human
it's
purpose, right?
just, yes, it's just for you to see. And maybe if you're having an error somewhere, you maybe try like printing out your sensor values to be able to be sure that your error is not coming from your
Troubleshoot.
sensor values. Yes, you understand that. So that is just why you need this anyway.
Sorry, Helen. I
Okay.
think I saw the serial monitor in the Tinker card.
Sorry, you saw the serial
You know, that's
monitor
what
there?
in the Tinker card. Yes, I think that's the reason why it came to. It's in the Tinker card.
Yeah, it's still in the Tinker
Yes, nice.
card.
Yeah.
It's still there. So, but I just
So
wanted
we
to
can
like
use,
explain the
use
concept physically so that you understand when you are building something, this is exactly why you need it.
okay.
I think the photoresistor I have here is not even working. Because this is not what it's supposed to read. 14 is not. And even when I increase the light, it's not reading the correct value. So I think I have light here, so it should be more than 14. Not reading the correct value. So just get the concept of how the photoresistor, and then all right, I can just do this. Someone's asking if I'm supposed to do an if statement or something. Yes. So you can still see my screen, right?
Yes, we can.
Okay. Can you still see the serial monitor, or is no longer there in your own?
We can see the serial monitor.
I've already closed the serial monitor here. Okay.
Okay, it's closed now.
Okay. All right. Now I've seen that this sensor is reading 14, right? So I've seen that the sensor is reading 14. I can just like if LDR. So what I wanted to do was I will increase the light in my room. I will switch off the light. I will increase the light, and I will know exactly the number. I don't know the number that the sensor is reading when the light is off. Do you understand that? I know the number that the sensor is reading when the light is off, so that I will use that number to do my conditional statement. So yeah, I can just say if LDR reading is equal, remember I changed something, right? So this is a logical operator. We use double equal to, no longer the single equal to. The single equal to, that means we are assigning a value to something. But the double, that means we are checking for something. And some languages will still have three. All right. Equal to 1. Let me say 14. Then what should happen? Digital right. Sorry, equal to 14 is wrong. You know that this sensor, apart from that, the one I have here is just reading 14, 14, 14, and it's not working. You know that this sensor doesn't just have one value. It can read 14 now, read 15 again, read 14, read 15. So what we have to do is, if it is less than 14, so we know that from anything 14 up, there is light. There is light. So then we off the bulb. So LED low. We off the bulb, and then else. If you understand what the else means, that means the reading is not less than 14. The reading is greater than 14. Okay, sorry. If it's less than 14, that means there is no light. There is no light. It's going towards 0. That means there is no light. So the LED should turn on. But then if it's greater than 14, that is else. Assuming it's not less than 14. If it's not less than 14, that means it's greater than 14. All right, so LED low. And I will upload it to my board. All right, so that is it. You can just write your if statement on the Tinker card. And I just play around with the values. Just play around with the values. It might not actually be 14 in the Tinker card. Maybe it will be 100. When you increase the light, maybe it will be 100 or so. I have something here. Let me just, the last thing I'm going to do is to work with the relay. So let me just do that and then we are done for today. All right, can you see me, right? Sorry, can you see me?
Yes, we can.
Okay, so
Yes.
this relay that I'm
Yes.
talking about, the relay that I'm talking about, you can see this.
Yeah. Can see.
So this is a relay. But if you notice, this is a 4-channel relay. We have 1, 2, 3, 4. So this is a 4-channel relay. So this relay like this can power up to 4 items. But then you can see this. Oh. You can see this, right? So this is a 1-channel relay. One relay for each device. So one relay for each device. This is a 4-channel relay. This is a 1-channel relay. And I also have a 2-channel relay here. So this is it. All right, I don't know if you see, you can see that I have a fan here. Okay, I have a fan here and this is the wire of the fan. All right, so this is the wire. Now I'm just trying to show you how this relay can be able to power the device. I don't know, to be able to power the fan. Okay. Arduino can only give out 5 volts, but we need to power this fan through a command from the Arduino, right? So that is why we need this guy to help us. And we are going to connect the relay to this fan. All right. So yeah, someone was saying something about the normally open and normally closed. Sorry, I interchanged it. All right, I interchanged it. So when it's normally closed, then the current will flow. But then when it's normally open, it can't flow. Okay, I don't know if you can see this very well. If you can see, this is the red wire. This is the live wire of this fan. When it's direct like this,
Your video.
when it's together, then I can plug the fan and the fan can just work on its own. But I just cut the positive wire of this fan. I cut it. I separated it. So if I plug it now, it will not work because these 2 wires are cut already. I don't know if you can if you can see that. Sorry, you can just wave if you can see that. All right. So I just cut it so that I'll be able to attach this relay to it. So I think I've already shown the relay. I've already shown you guys the relay. So I have the normally open, have the normally closed. So you might not actually see it, but maybe you can just view the relay from somewhere, okay? And just see this is normally open, this is normally closed, and this is the normal. The middle one is the normal. So it's not in any state. It's not in open, it's not in close. So it's just normal. Now, this wire is cut into two, but then the live wire connected to the plug, the live wire connected to the plug is what I'm going to plug at the middle. I'm going to put it in the middle pin. And then this other wire, I'm going to put it at the normally open, So now with these pins here, I'll connect it to the Arduino, and then when Arduino send the signal, it can just trigger the relay. It can, I told you the relay acts like a switch. So it can just like switch on, off, just attach it to the normally open, attach it to the normally closed. So when it is in the normally open, the current can flow, and then the fan will be off. But when it's in the normally closed, then the fan will be on. Current can flow through it. All right. Okay. I think I'll just be fast with this. I don't know if you actually understand what I said I'm going to do. All right. I think I missed something. This is my 4-channel relay. There are relays, though. There's a kind of relay that is a low-level trigger relay. So there is a relay that you will get when you write digital write high, the relay will turn off. And when you write digital write low, the relay will turn on. Okay, so normally, when you send high, that means you're trying to power the pin. And when you send low, that means you're trying to like remove power from the pin. But then this relay, this my 4-channel relay, is a low level trigger. So it's when it's in its low state that it will on. All right, so if I actually want to on this fan, what I will write is digital write low. That is if I'm using this. What I will write is digital write low. And I think I'm going to use this. So just for you to understand, so that when you see exactly what I'm doing, you will know. Okay, this to the middle. All right. It's connected already. So what I'm actually going to do, I'm just going to automate the fan alone. Okay, all right. I think I need to upload the code first. So let's just go to exactly what we want to write for this. Remember, when we the relay is actually what is connected to a pin, and I connected my relay to pin 4. So whenever I send like a high signal, according to what I said about the particular relay I'm using, is only when I send a low signal that relay will on. So when I send a high signal, it will off, and when I send a low signal, it will off. So int relay is equal to 4. Then let me define the pin mode. Pin mode relay, and that's an output device. Then this is what I want to do. Digital write relay high. Okay, then I will delay it for like, so that the fan can I'm going to give the fan like 15 seconds. That is I'm going to give the wheel 15 seconds to stop. Then I will turn it on again. So let's say 15,000. Then digital write low relay low. Then I'll turn it on again. Okay, I think let me just all right, then delay. Okay, so I don't know if you actually understood what I did. Okay, yeah, this is supposed to be high here. Sorry, low there and high here. Okay, did you understand my code?
Yeah, we do.
Okay.
But I do.
Remember, okay, remember that the low is going to actually turn the relay on. So the low will turn it on, and it will be on for 15 seconds. then the high will turn it off. Remember, it's a loop, it will go to the top again, turn it on again, wait for 15 seconds, then turn it off. So that is the goal of whatever I'm doing this night. All right, so let me upload it to the Arduino.
Sorry, but why? Why is low turning on, high turning off?
Okay, so that is exactly what I explained before. I think where is the relay? The relay I'm using, it will be written on it. It will be written on it. If your relay is a low trigger relay, this is someone that did it, right? According to what I said, someone actually like did this module. So, and they will write on it low level trigger. All right, so if you see the low level trigger on the relay, just know that it's low that will trigger the relay. I don't know if you understand. It's low that will trigger the relay, not high. When you write high, then it's going to turn off the relay. If you write low, it will trigger the relay. So my single channel relay that I have here is not low level trigger. I can use high to trigger the relay. But then this 4-channel relay, I just bought it and I'm like, I looked at the back. And you know, when you're growing, you'll be exposed to some things. So I've never ever used this kind of relay before. I started making my research and I got to know that yeah, they have low level trigger relays. I don't know if you got that.
Yes, I do. Perfectly. Thank you.
Okay. First, I'm going to name this, I think, like auto fan. Save. So I have to save before I'll be able to upload. All right, done uploading. So I'm going to use a battery to power this though, so I'll be able to show it clearly. I have my GND 5V and 4, right?
Yeah, we can see your video.
Yeah, I'm going to turn it on. Sorry for that. All right, so this is it. This is exactly what I did. You can see the Arduino connected to the relay and then to the wire of the fan. All right, remember that this is the plug of the fan. So I'm still going to plug the fan. I think let me just get an extension. The wire is not long, so I have to bring the extension closer.
Hello. In the loop,
All
of
right.
this relay,
Yes.
I'm guessing that the effect of when it turns off will not be seen. Do you have like you don't have to delay it after it turns off, like in the eye section after the eye?
Yeah, there is need for it to be
Okay, I
delayed.
think the yeah, there is no delay when it turns off. Yeah, yeah. All right, let's say let's delay that for 10 seconds. 10 seconds won't be enough for the blade to stop, right?
Depending on the kind of fan you're using, though.
I think this fan, I think let's say
15
20
seconds should be okay.
seconds. Let's say 20 seconds so that the blade will turn off completely then. Yes, so I have to upload this code again.
What about the circuit diagram? I don't know. Can we probably see it or something? Because we didn't see on any. We just saw you writing the code. We didn't see the connections.
All right, I will. I will show you that.
Thank you.
All right, let me plug this and upload the code. All right, I'm done. All right. Can you see me?
Yes, we can see you.
Okay. All right. I know that this fan is going to rotate, so I'm just trying to see. Because if you rotate, the wire might actually drag this down. So I try to look for a way to place it so that even if it rotates, it won't drag it down. Since I didn't like package it very well.
Okay, I hope your there is a safety in what you're doing.
Yeah. I think I'll have to use a tape to cover up this naked wire so I don't touch it.
This is really amazing.
Sorry, can you see
Yes,
the
we can
fan?
see the fan. Yes, we can see the fan. We can see the fan.
All right. Okay, thanks. Let me turn it this way. Is it better this way?
Yes, we can see the fan.
Is it better this? See the connection, right? This is the Arduino, and then the other end is connected to the extension. All right, but as you can see, the fan is not on now. So I'm like going to power this. I'm going to power the Arduino board by connecting this battery. So I'm going to use this battery. The battery connector is here. I think the battery connector is here. So yeah, that's the battery connector. And I'm just going to do this. Did you see that? I don't know if you saw what happened.
Yes, we did.
So immediately I connected the battery. Yeah, the fan wanted to work. So the fan is working now. All right, so let me just watch it from here. Did I touch it? So as you can see, I'm just holding the fan so that it will not drag this down. All right, so you have to be the judge now. Is the code working or not?
Yeah, it's working.
So you can see it will switch on, then stay for like, was it 15 minutes we said? So stay for 15 minutes and then it will switch off.
15 seconds.
Yes, and then it will switch off, stay for 20 seconds, right? And then switch on again.
Beautiful.
And I don't know if you are hearing that sound came before it will come on, right? Can you hear that sound?
Yeah. Yes, we can. We can hear
Okay,
it.
just wait for it to come on again. You'll hear that sound came. All right, did you hear the sound?
Yeah, that's
Yes,
a relay.
kind of a switch.
So that is the relay. That is the relay. Like that's the sound the relay makes when it comes on. So when you hear that came, the relay is on. Came, yeah, you heard it now. So the relay is off now. So that is it. Yeah, if maybe we want to control it with voice, you know exactly what we would do. In this our connection, then we have to add the Bluetooth module and then write the code. So it's just like this, just like this. That is it.
Nice one.
All right, so I'll just disconnect the battery so it will start. Yeah.
So my
All right.
question is, like, my question is, what if you want to, like, I want to pay for a house? This the Arduino board is there, it will pay and everything. So where are they going to be? Like, I want to do a connection for like a building or something. Does the Arduino board has a cover? So
Sorry, I didn't get that.
okay, so let's assume this is an experiment. Like, I want to actually implement it for a client. You know,
Okay.
so most of the relays and they're all open. So how do I how do we put them? Are they going to be in a box? Do they have covers? So to make it more today. So that's the question.
Okay, well, now this is just because I'm just trying to do my own thing now. If eventually
Right.
I want to wire this house, are you getting me? If eventually I want to wire this house, then it's not going to be like this. Well, let me unplug this fan before I touch something. Okay, so if eventually I want to wire this house, then it's not going to be exactly this. Just for you to understand the concept, right?
Yeah, I know. Yeah, I
Any
understand.
wiring we want to do, we need negative, right? We need positive.
Yes. Yeah.
All right. So it's just to get the negative and positive of the house. All right. It's just to get the negative and positive. For example, I want to wire this my room now. Like I want to wire the bulb or something. That means I have to like cut through to where they did the connection. All right.
Okay.
Get the negative of this bulb now. Get the positive. And then maybe like a small box. Okay. I can, like I said, there are different microcontrollers. Arduino you are seeing now. Arduino self is big. You get, so Arduino is even big. There are other microcontrollers that are small, like very small. We have the ESP32. I don't know if I can see ESP here. All right, yeah. Okay, I don't know if you can see this. Can you see this?
Yeah, I can.
This is a microcontroller.
Oh wow.
This is a microcontroller. So all these pins you are seeing here, if you look at it very well, the digital pins are here and the analog pins are here. So this is a microcontroller. Assuming I want to do something that I don't even want it to be visible, you get. I can just use a smaller microcontroller to do it. Okay, maybe put a box and then I can put a switch. Okay, maybe I don't want the Arduino to be on every time, you get. So let's say Arduino now is the control panel. Maybe I don't want it to be on every time. I can put a switch whereby if I just switch, then the Arduino will turn off. That means it will not receive any automation again. That is.
Yeah.
Then if I want to, it's just like, I don't know, it's just like this bank door. There are sometimes you want to enter, they have this like switch off the system.
Yeah.
I don't know if you've experienced that before. The door won't be able to open and the door won't be able to close. It will just be locked the way it is. That is because they switched off the system.
It's more like low separation, because I do solar and inverter, so it's more like low separation, separating the load and all of that.
Exactly. So you can just switch off the entire system and everything. So you can just like connect it and then make the Arduino the control panel or something. Maybe drop it somewhere in the house. Do your wiring through it. I don't know if you're getting me. So and remember, this Arduino is something that someone else have already built on. Okay, so the ESP, I think the microcontroller is very small. So the microcontroller of this is very small. So remember that this is something that someone have already built. So this is just the small thing in this journey. At a point, you will have to like think, let me get this. We won't be using this board. This is exactly what you need. This. If you followed me the first day, I said something about the microcontroller. I said this is a development board. So someone already extended the input and output pins for you, but then this is the microcontroller. If I remove this board is useless.
Yeah, it's a brain box.
Yes. So I can just make use of this. I getting me? I can just make use of this. And then if you are someone that is well conversant with the electrical parts and everything, you can build the circuit with just this instead of needing this big Arduino board.
Oh, okay.
So you understand what I mean? You can just build the circuit with this. Here, and you won't have to need this big Arduino board.
Well understood. Yeah, thanks.
Okay. So so that is it. If it is for this fan, if it is for this like this electric standing fan, that one is even very easy because I can just enclose the Arduino in a box and attach it to the fan, right? So the fan will keep moving based on the thing Arduino is telling it to do and all that. But for a house, you can just have a control panel where you place it and then connect the other wire of the house through it. So it will still require creativity.
Yeah, obviously. Obviously.
All right. So I don't know if I've been able to like help you to understand the concept of IoT, how all these
Yeah,
things work. So you can see that I just connected the battery and then Arduino is the one telling it, oh yeah, off, on, off, on. We are not even doing anything there. So assuming we have the Bluetooth module, I will connect the Bluetooth module and then I can just say from my phone. From my phone, I can just talk. And then it's just like the serial connection I'm talking about. All right.
yeah.
If you notice pin 0 and 1, I told you that they are the receiving and transmission pin.
Transmission,
So the
yes.
yes, if I want to connect Bluetooth, that means I should connect to pin 0 and 1. So if I connect the receiving pin, I will connect the transmission pin. And I can be able to talk through Google Voice. I can be able to talk to my phone through Google Voice and it will translate it to text and send to the Arduino.
You know.
All right. So based on what the Arduino received from that Bluetooth, it can be able to perform action.
Yes, so you should apparently you will actually the app for that. There's no app for that, right? Hello? For the transmission and everything through the phone, you actually need an app for that. And I don't know app or how does the connection work?
Yes, you
I
need
think you need
an
the app.
app. You need an
Yeah,
app.
then app. So you can and
You need
even from
an
the app,
app.
you can actually program it too from the app too. So some app, I think some app should have some code, some stuff they've already did that can just work on already.
You can actually find those apps in Google Play.
Oh, really? Okay.
Yeah. Like the one I use, if you have seen the voice control thing I did, the one I used, I got it from Google Play. I didn't build it. So, but you
Oh,
can still
okay.
build it with Flutter. You can still build it with Flutter, Java.
Okay. I know Java that year. This one.
Okay, so that is it. If you build this, it's just looking like one kind big thing like that. So if you can just understand the concept, how this works and all that. So which is my reason for organizing this class. This is just what I wanted to like show you.
Thank you.
All right, so you can just try out. Admin is a bulb that I wanted to automate. Just like don't worry, I'm going to send you the circuit diagram. So I'm going to send the circuit diagram of how the relay is being connected.
Okay, and also please, the slide you're using, the slide, I don't know if possible if you would be releasing the slide though. The slide is
All right,
teaching
fine.
us. Yeah, so we can actually still go through on our own too.
Okay, I think I'll just include the diagram on the slide and then just give out the whole document.
That's generous of you.
Okay, thank you, Require. Do you want to say something?
Okay, so I said the way I
I think
understood that and
what you said. I didn't get that.
okay, I said in yesterday project which we did, which was the day and night project. So I did notice something yesterday which I'm going to point out. So the way a photoresistor work, which I understood, is when it sees a lot of light, the
Okay.
resistance decreases, which means that there's a lot of light and allow high flow of current. So, but yesterday, the way we in the
Okay.
loop program, the if else statement, it says that if the intensity of the light is less than 25, that it should come on, right? So
Yeah.
the thing about that is that if you're going to reciprocate that in real life, um, I think it's going to work in the
Okay.
opposite way.
Okay. To
So
turn off at night and then to
yeah,
turn
it's
on
going to
during the
work in the
day.
opposite way because if the resistance is like less than 25, that means that there's a lot of light. It means that it is in morning. So we are telling him to come on in the morning and vice versa. So that's what I just noticed. And
Okay.
my second question, okay, my second question is that I understand it's still about the second project too. So the photoresistor. So I understand that we kind of tweak, we write it that so that we maintain a threshold that okay, this is the command when this light falls below this threshold, turn on. When it goes above this threshold, come on. But I also understand that the way an LDR is supposed to work is maybe when we want to use it in a light dimming, like the amount of the way the resistance decreases, the light will be dimming. You understand? So, like,
Yeah.
how are we supposed to implement that in code? So, this is just a direct command we gave in the day and night. But in case we want to use it in a light
Yes.
dimming program,
Okay. Think. Sorry, let me get something. Okay, you're talking about the light dimming, right?
yeah.
All right. Now, this is just one of the examples of PWM. Can you remember that?
Sorry, what do you say? TW what?
PWM, pulse width modulation pin.
Okay, pause frequent. Okay, yeah.
Uh-uh. Are you serious? Have you forgotten that already?
No, I do remember what you said about pause width. But you're talking about that in motors, right? Rotating the tire of a robot or something.
That is continuous stream of output data. Did you get me?
Yeah, yeah, I did.
All right. I don't know you guys actually forget that easily.
Yeah, I think the thing is it's actually easier for us to remember, especially the one you put in practical in the simulation. So a lot of theories don't really come in and then except we go back to it, or maybe we have a lecture note or something. So I think the practical aspect is what stick, especially the fact that we didn't really like use the PWM in any practical or something. So I think many people are likely to forget
Okay.
that.
Okay. Now, I told you guys that digital pins, right? You can only read and write 0 and 1. Anyway, not read. You can only write 0 and 1 to it, right? So it's either high or low. High or low. But then I talked about the motor, that a motor is an output device, right? So definitely we won't connect it to analog because it's not an input device. Okay, now you can still connect your like output device to analog, but that is only if you have exhausted the digital pins of the Arduino. I don't know if you got that. So there are just 13 digital pins, at least, and 11 are the ones that you are expected to use. So if you have like more than 11 devices to connect, I get me. Maybe more than 11 devices that your digital pins are exhausted already, you can use your analog as digital. All right. So, but let me not go there. I think by the time you keep building projects, you come to a point where you've exhausted your digital pins and you need to connect something else. Then maybe you can be able to go to that by then. So now the PWM, I said that. What about the motor now? That is the robot motor, the rotating motor, is an output device. But you know, you don't just write 0 or 1 to that motor. I don't know if you're getting me. Because even for the motor to stop, you need to be reducing the speed. You need to keep reducing the speed before the motor will now stop. It's just like use the motor you are driving as an instance. So when you are driving at a high speed, right, you want to stop. You don't just stop the motor, bam, and it will stop. You need to keep reducing the motor speed and then now stop. I don't know if you got that.
Yeah, I got that for sure.
So the motor is not just high or low. The motor is not just on or off. You need to also write the speed, which is usually through the amount of voltage that the motor is getting. So if you increase the voltage, the speed, will increase. So you're not going to, if you want to write to that motor, you're not going to write 0 or 1. You can write 100, 105. I don't know if you're getting me. So the more you increase that number, the more the speed of the motor increases. But then, for digital pins, you can only write 0 and 1. So how do you tackle this kind of problem, like the problem of this kind of motor? Then you have to use the PWM, pulse width modulation pin. If you connect that motor, this motor that you want to write something that is not 0 or 1 to, if you connect it to a pin that is not PWM, it will not work. I don't know if you got that. So it's not going to work. But if you connect it to a pin that is labeled PWM, then when you want to reduce the voltage, you can write from 0 to, I think, 1023, and then it works. So it's just like continuous stream of output data. All right, instead of the input data, the normal input data. So it's continuous stream of output data. Now, what brought about this is the dimming light that you talked about. The dimming light that you talked about. If you actually want to dim that light, then you need to use the pulse width modulation pin. Did you get that?
That is one of the digital pin which is either 1110.
Yes, yes, which is either 1110. I think 12 is the amount.
No, 12 is not amount. 6, 5, and 3 is amount.
11, 10, 9. Yes, 11, 10, 9, 6, 5, and 3.
Yeah.
Okay, because you are going to be writing voltage to the bulb. Did you get that?
Yeah, I get.
So you're going to write, instead of writing 0 and 1, you're going to write voltage to the bulb. Okay, I don't know. I'm just going to give you that concept, and maybe you should practice it. I won't really do something there.
Yeah, okay, I understand, but with that we go into the condition of that means that the condition in the if is going to be a series of possible lower resistance, right? Or maybe a
Yes,
possible
yes. It's going to be just a series of possible lower resistance. Something like if the resistor, the photoresistor, the value, if the value is less than this, then dim it to some point. I think I will just show you the code for that. Then dim it to some point. Then if it's now less than this, dim it to the other point again until it will off.
Okay, so that means that is going to contain some if else else statement. I don't know. There's no else
Yes,
statement.
some if, else if, else if, else if.
Okay, I get that now. Yeah, a lot of else
if,
statement.
else if, else if, else if.
Okay.
Yes, I would have said, okay. I think when the photoresistor when is reducing, right?
Yeah.
Okay, let me see. Okay, because I wanted to tell you that you can actually write with the photoresistance distance, with the photoresistance value. I don't know if you're getting me. Maybe the value of the photoresistance is 24.
Yeah.
Then you can write 24 to the bulb.
Okay. So like instead
Did you
of
get that?
using a less than, we can just like equals when equals a certain
No,
resistance.
you won't even need that else. You won't even need that conditional statement again.
Okay.
You won't need it. You can just like read from the photoresistor, right? Then write the value red to your bulb.
Okay.
Did you understand?
Yes.
So if you read like 24, that means there is highlight, right? If you read like 24, then you write 24 to the bulb. You know the bulb will go dim.
Yeah, I get.
Yeah, then if it's something like 100, so you won't even need that if statement again. Just in your loop, read the resistor value and then write
So we
it to
just
the
keep
bulb.
reading it, and maybe we don't need a
So
delay.
you
Right?
just keep reading it. The loop will just keep reading it again, and then keep writing whatever is reading to the bulb.
Yeah, in that case, we won't need a delay, right?
Yeah. Maybe you can even add the delay. Maybe after some point, read again. After some point, read again. Or you can just leave it like that. So why it keep reading it to keep updating it? I don't know if you got that. So since you can actually write values to this bulb.
Okay, that makes sense. Thanks.
Yeah. So you won't need an if else statement. You just write the value you read to the bulb, and it will work like that. The same with this potentiometer. You know the potentiometer, right? That you can increase and reduce. So.
Okay, thank you.
Yes, that is that. So you just have to make your research and get the way to write to the analog this thing, because you have to use math. You have to use math to write to the this thing, to write to that bulb. Okay. I think I'll just leave it here, but with the whole concept, just check for a way to write to the bulb and all that. But you know that you won't be writing low or high. You can write other values too, but you must be connected to the PWMP for that to work.
Yeah, thanks. I'm going to like check up on that. So I think I'm kind of clear the way you explained. So
All right, thank you. So sorry for taking your time like this. I don't know. So wow, this is after this. Anyway, thank you guys. So I think this is our last class. So with the knowledge you got, you get your starter kit and then keep building. Keep building. At least you have learned how to use your code to control whatever device and all that. So. And the more you practice, the more you get exposed to other things and you learn. So thank you guys. Thank you. No, Emmanuel. Is that your question? Uche and Emmanuel, you're raising your hands. Like, do you have a question?
Mine is kind of like a vote, thanks though. No question.
Okay. Thank you so much.
Yeah, I
Yes,
really
thank you
appreciate
so very
your
much.
work. Really appreciate. It's not easy, I know. 4 hours. 4 hours, I think.
Yeah.
Thank you so much.
Thank you very much. Thank you all for coming around too. I don't know, it's like some people gave up on the way because
No, it has
so I
extended
think
beyond
I
their
took
time
you
of.
people into the spirit this night. So some people gave up. And I know it's only the electrical students that are still here with me. I'm not wrong.
No, no exception on me. Oh, I'm not an electrical student. So.
There are some mechanical students. So
Oh,
No,
yeah, that's
I'm,
true. The
I'm
mechanical and
electrical.
electrical.
yeah,
I'm natural
I'm
student.
electrical.
yeah.
Wow.
Thank you.
Wow. Do I still have any
Natural.
programmer here? Any JavaScript
Yeah.
developer here?
Yeah, JavaScript developer. It's Puche. That's
Okay,
why I could be
okay.
doing the job. My job demand IoT fully, so I have to just.
Okay. Oh, wow.
Since I have to link up with you, I'm okay, right?
Yeah,
Uche.
it's fine.
The name is Uche. Required. I'm seeing you. Your profile pic is just funny though.
Oh my, that picture is how many years ago? You see, it's like 20 years or 10 or 12 years ago, something. You see,
Is this Immoral? I can't pronounce the name. I was thinking it was Emmanuel.
yeah, it's Emual Joseph.
Emual. Okay.
Emual Joseph. Don't mind that picture. Don't worry. How would I link up with you now? Maybe just drop your.
You can. We are in the group now. On the group. You are in the
Okay.
group now.
What's the name on the group?
My name is Uche. It's just straight up Uche. Uche.
Okay, don't worry. I'll send you.
We also work together. Just trying. Well, that's ourselves Christians, though. It did not end here, though. Helen is on Twitter. You can follow ourselves on Twitter and make things better.
Yeah, sure. Very important. Very important.
Okay.
Very important.
Nice to meet you all, guys.
Yeah.
Yes.
Thank you.
Yeah, thank you, sir. I think you are the first person I've always been seeing. I don't know. And I've not heard your voice before.
Who knows?
No, he has speaking all this while. He has been speaking all this
Are you
while.
serious? Maybe I didn't even know he's the one talking. He's the one, the first that is appearing on my meets.
Okay.
Bye. Good night to
Oh,
you
wow.
guys.
You should open the group. Oh,
Well, good night to you all. Jay.
you know, like,
Jay, right?
Bye. Yeah.
Joe, yeah.
Okay. Well then, well done, you all. Thank you so much. All right, good night.
Required. Well done.